when null value involved, we need to use some special rule about the null value. So when we do the grouping, how do you choose a right way to group those rows with null value? Yeah. So the rule is this. If nulls exist in the grouping attribute, then a separate group is created for all tuples with null value in the grouping attribute. Yeah. All the rows with null value we treat as one group. Yeah. Here, you need to compare the property we used before. We have the previous rule related to the null value. When we compare two rows, they have the same value for a particular field. Oh, it's not the same value here. They have the same null value for the particular field. Then we treat as different values. Yeah, that's the rule we used before. But here, this is grouping. So this is a grouping. Define a subgroup. When we define a subgroup, then we treat. So all the null values, we put them in one group. And when we apply the aggregate function, we apply it on this group, null value group. All right, so let's look at an example here. How many employees are supervised by each supervisor? Yeah, each supervisor, right? So we want to count the number of employees supervised by each supervisor. But when we look at the values of the supervisor, there are 7 in our employee table. Total number of rows, 40 rows. 7 of the 40 rows, their supervisor underscore SSN are the null value. Yeah. So we need to consider that special case. Right. Select count SSN from employee, group by super underscore. Yeah, I should write here. Super underscore SSN. Yeah, if for non-null value, yeah, regular values, each value is used to define one subgroup. Yeah. Okay? Yeah. One subgroup. In that subgroup, multiple employees are supervised by this particular supervisor. Yeah, but after you finish all the regular supervisor super underscore SSN, you have remaining 7 rows. Their super underscore SSN values are null. So that's one group. Okay? Yeah, that's one group. All right. So the result, you can see the first group, subgroup 7, okay, 7. That's the null group, okay. Count, yeah. So those 7 employees, they are, as we said before, they are top level supervisors, right? Yeah, top level, yeah, because these 7 employees have no supervisor above them, okay? No supervisor above them. Null value, yeah. So other than these 7, yeah, the remaining employees, so here, supervisor, each one corresponds to one, right, one supervisor, okay, one supervisor. So this supervisor has 3 employees to be supervised. Okay, that's the meaning. Yeah, and so on. Yeah. All right. Yeah. So then, based on this understanding, because later I may give you a question. Yes, here I want to, based on this property, I want to describe. Remember when we apply count function, sometimes we use star, right? Sometimes we use a field name. Sometimes we use star. Sometimes we use field name. Okay? Yeah. So another case is, let's say, for the F1, okay, field 1, okay, all right, to count the number of rows in one subgroup. Now, here the question: can you see the difference when we use star F1, star F1? You know, F1 would mean the field name, okay, based on the field name. For example, SSN is a field name, right? SSN field name. So here I use a field name here. Yeah, these two ways. Do you feel these two ways would result the same thing or not? Same thing or not? Okay, think about that. Yeah. So here, the answer related to the null value. This one, even null value, we need to count, right? Yeah. You count those rows, even the null value. There is a row, you count it. Okay? Yeah. Null value, you should count. Okay? This one, if the F1 value is the null value, then you do not count. Okay? Yeah. Yeah. All right. Yeah. So here, yeah. But because here, that's the subgroup, okay, all subgroup. So then there is one separate subgroup. So you count, all right? But when you apply, so here, let's say, let me give you more. Let's assume this F1. I should do this. We count this F1, but null value, okay? Yeah. Several null values, okay? Yeah. Then non-null value under this F1 field. None. Right. Yeah? So here we count with respect, so we apply count function on one group. So here, one subgroup. This subgroup contains, for some rows, non-null value, but for some rows, null value. Yeah. So then you apply it on it, so you do not count those rows with null values. You only count those rows with these non-null values. Yeah. So here, what I mean is one subgroup. Okay, all these rows are in one subgroup. It's different from the case here. Okay, the case. Yeah. So you separate them. Okay, separate different subgroups. Yeah. So one special subgroup. But here, when we use this, we assume we apply this function on this field for one subgroup. Well, one subgroup. Yeah. Yeah. You just imagine the whole table. So here, suppose here, okay? Yeah, so here. Yeah, in order to separate these two cases. Suppose here, we do not define subgroup. What would happen? We remove this group by clause, okay? We remove it. So I ask you, apply this query without define subgroup. If we do not define subgroup, what's the meaning? The whole table is treated as one subgroup, right? One. Now you need to apply this count function on the whole table. You can only return one value, right? One counting value. You cannot return two values, right? Two values, one for null part, one for non-null part. You cannot. Okay? You can only return one single value. That single value, you do not count the null part. Okay? That single value, you only count non-null part. That's what I mean. That's what I mean. All right. Then, if I change this SSN to star, yeah. So here, because we have an option. Sorry. Yeah, I should write here. We have one option: replace SSN by this star thing. All right. Then that's different. If you use star here, you need to count the 7 rows with the null values. Yeah. So if you use star, this will return 40. Yeah. All the rows, 40. If you use SSN, it will read 33. 33, because excluding those null values. Okay. Yeah. So that's the meaning. That's the difference. Okay. That's the difference. Yeah. So when you see star, non-star representation, you need to consider null values. Immediately you connect to the null values. Yeah. All right. Yeah, because in our next quiz, I will give you that question. Okay. In the next quiz, there is one question is designed to separate these two results, two different results. Yeah. All right. Then another example: a join condition in conjunction with group by. Yeah. Group by. Yeah. After you apply group by, you define a sequence of subgroups. Then sometimes you may want to apply another condition on each subgroup. That's possible. Okay? Yeah. So a join condition in conjunction with group by clause. Yeah. Yeah. When I graded your midterm, yeah, a few students already used it this way. Yeah. So let's look at this example. For each project, retrieve the project number, the project name, and the number of employees who work on that project. Yeah. Look at the question. Here, first, you can number of employees who work on that project. That means for each project, you need to count number of employees. Yeah. So when you define your subgroups, you should use the project number, right? Project number, project name, project number. Here, two fields. Two fields are mentioned, but when you define your subgroups, which field should be used? Yeah, that's one question. Another question, when you count, you need to count the number of employees in each subgroup. Yeah. All right. Yeah. So let's look at the answer. Yeah. Project number, project name, count. Yeah. All right, define. Yeah, because this time we need to join project and works on table. Yeah. Join condition, yeah. Group by when we define. So here, we should be careful. Yeah. Because when I did grading, I saw several students made a similar mistake here. Yeah. Let me explain the problem. Yeah. Not big problem, but redundancy problem. Like here. Group by when we define subgroups. Here we use two fields. P number and P name. The question is, is it necessary here? Is it necessary we should use two fields? What's the difference? Yeah. Here, think about, if I cross out P name, I just use P number to define subgroups. Is there any difference? With or without P name, can you see any difference in subgroup definition? No difference. Why? Yeah. Can you see between these two fields, P number and P name, is there a one-to-one correspondence? One P number corresponds to one project name, one-to-one correspondence. Okay? One-to-one correspondence, if you pick one, then the other one is determined, right? Yeah. When you pick project number, the project name is determined. Yeah. So you add a project name or not, no difference. You do not add anything special. Okay? You do not add anything. One-to-one correspondence. Okay? Yeah? Yeah. Yeah. So, in this situation, then we should choose the minimum number of fields. Minimum number of fields. Yeah? See? Yeah. So, you use some unnecessary field, yeah. So you may need to do more work, right? Yeah. Yeah. So because to define subgroups, P number is enough, or P name is enough. Yeah. The other way, P name, just one, is enough to define project subgroups. Yeah. So when I did the grading, I noticed this problem occurred many times. Yeah. So ESSN already is enough to determine the subgroups, yeah, employee subgroups. Then they use some more information. Employee first name, employee last name. Yeah. Then ESN and the first name plus last name, it's a one-to-one correspondence. So why you need to use redundant information to define subgroups? Yeah. Yeah. So several students did that. Yeah. All right. So that's one question, common question. All right. Grouping function applied after joining of two relations. Yeah. So you join two relations first. Okay. Yeah. So this part. Yeah. So you do this part first. Okay. Yeah. So you join two tables first. Then after you join the table, then you divided your joined table into subgroups. Yeah. Into subgroups. Yeah. By this criteria. Yeah. All right. Same as, yeah. So here I simplify it, yeah, because it's redundant. So I remove that P name. Yeah. Yeah. All right. Yeah. So when you work on questions like this, yeah, after you define your subgroups, you need to check if there is a one-to-one relationship among some of the fields. Yeah. Sometimes students use 3, 4 fields. Okay, yeah, several fields. Then you need to examine if there exists some one-to-one relationship. You should remove some of the fields, yeah, because part of the information given, then the remaining part already determined. If they're determined, why you need to add that? Okay, you do not need to attach something just does not change anything. Yeah. the added part does not change your subgroup definition. Yeah. So that's the reason you can simplify it. All right. Then inner join, outer join. Yeah. So we need to learn this concept. Mainly outer join. We do comparison. What's the difference between inner join and outer join? Yeah. All right. Inner join. Yeah. So far at this point, all our questions are inner join questions. Yeah. That's the default type condition. A tuple is included in the result only if matching tuple exists in the other relation. Yeah, because there are two relations. Yeah. So the matching table A, table B. Yeah. So you have a join condition to join table A, table B. Yeah. But if in your join condition, if one of the value is null value, you throw away, right? Yeah. For inner join, yeah. So inner join, yeah. Let me write this way, okay? Yeah. Recall for the inner join case. Inner join case, okay? Here, let me write this way, okay? Yeah. Tuple in table A, but here, because here we only compare the field, one field to join, right? Yeah. So let's say field 1, okay? Yeah. This is our join condition. Tuple B, F2. All right. This is our join condition. If any of the two is null, we skip it, right? Yeah. Yeah. If the null value, if this null value, yeah, we do not include it. Okay. Yeah. If one of the two null value, join condition fails, right? Yeah. Yeah. If this one null value, yeah, because yeah, based on our it fails. Fails. Because when you do comparison, this if there is a null value, the result is unknown, right? Yeah. If null value appears at any side, the comparison result is an unknown result. Okay? Yeah. Unknown result. Unknown result for inner join, we do not select, right? Yeah. Because we only select the comparison result true. Yeah. Your comparison returns true, then we select it. False and unknown, we do not select. Okay? Yeah. So that's for the inner join. Yeah. But then for the outer join, the rule is changed for this join condition, this type of join condition. Then we will change the rule. Selection rule will change. Yeah. So let's look at how do we, our new selection rule. Yeah. All right. Outer join, yeah, this time. Yeah. But for the outer join, when you choose outer join, there are two possibilities you need to specify. You apply outer join based on table A or table B. There are two cases. Table A case. Yeah. For the table A case, you should include all the rows in table A no matter what. No matter what is the comparison result. Okay? So based on table A, you should select all the rows in table A. If based on table B, you need to select all the rows in table B, no matter what are the comparison results. Okay? True, false, whatever it is, you need to select. Okay, that's the new rule. So you need to specify which type explicit. That's why we say left outer join, right outer join. There are two cases. Require that all the tuples in one table, one of the two tables, one included, even if no matching tuple in the, let me remove this. No matching tuple in the other table exists. No matching, you still select, okay? Yeah, because we want to get information for one of the two tables, first table or second table, okay? Table A or table B. We want to collect all the information for all the rows in table A. Yeah. If the joint condition is matched, we select. If the joint condition is not matched, we also select. Okay? We also select. Because that information is also useful. The non-matching information, the rows with the non-matching information, also useful. All right? So for that, that's the outer join case. One of the two, left table, right table. So we have two. Yeah. So the null case. Yeah? Yeah. Yeah. That means if not matching, then the value, we will use the null value in the non-matching field. Yeah. So that field, join condition, not matching, right? Not matching, you cannot use the original value of the field, right? So, but you can use the null value to replace it. All right. Left outer join, right outer join. Yeah. Two types. Okay. All right. Left outer join, all the tuples in the left table included. Okay. Yeah. So we want to collect information for all the rows in left table. Some of the rows, joint condition are matched, so we select them, no problem. But some tables, the joint condition, not. No matching. No matching. Okay? No matching, we use null value on that. No match on those no matching field. Yeah. All right. Right outer join, all tuples in the right table included. Yeah. That's the rule. That's the rule. Yeah. Yeah. All right. Yeah. And in some special situations, outer joins are useful. Yeah. Most of the time we use inner join. Yeah. Most of the time we use inner join. But in some small portion of the situation, outer join could be useful. Yeah. Yeah. All right. First, I give you one example, one simple example. Yeah. So we need to use outer join. Yeah. Then later, so I can, because sometimes we can use the special properties of outer join to help us get some special queries. Yeah. So that's also interesting. Yeah. Yeah. All right. Yeah. Let me show you the special example using outer join. For each employee, retrieve employee's last name and the last name of his or her immediate supervisor. Immediate, okay? Yeah. Supervisor. Yeah. Where an employee tuple whose value for super_SN is null is also included. Yeah? Because if immediate supervisor is null, you also include it. Because that information also useful, right? Yeah. So we don't want to remove those rows. Yeah? Because that null, those rows with null values for the immediate supervisor, also useful. Also useful. Right? Yeah. So we don't want to throw away. Yeah. So this case, yeah, we should use outer join. Yeah. Outer join, we do not throw away those null values. So the values super underscore SN with null values. Yeah. Inner join you will throw away. Yeah. The matching. When you check the matching condition on your join condition, yeah. When you see null value, throw away. Yeah. But here we don't want to throw away. Okay. Yeah. All right. So let me give you the answer. Yeah, select. So here you can see 2 copies. Yeah, yeah. When we join table, yeah, the same employee table, we have E copy, we have S copy. Yeah, 2 copy, but we use left outer join operation. So that means all the rows, yeah, left. Okay, E is left. Yeah. All the rows in the E copy should be preserved in your query result. Yeah. Even if the matching part is null, you need to include it. Okay? Yeah. Yeah. So left outer join. Yeah. All right. Yeah. So, all right. Then the join condition E dot super underscore SN equals S dot SSN. S dot SSN. All right? If, think about special case, if E dot super underscore SN is null, then you won't find S dot SN equals that null, right? You won't find it. Yeah. In that situation, yeah, you still you keep that row. Okay? So even super underscore this value is null, you don't throw away. Okay? You don't throw away that row. You keep that. Yeah. You take that null value for this field. Yeah. Yeah. All right. Yeah. So that's the that's already that's the end of part A, not part D. Yeah. End of part D. Yeah. But before I leave this page, so there is a special situation. Yeah. Yeah. Because the null value. So we can see when we apply left, let me just use left outer join, because right outer join similar. Yeah, similar. So we only need to consider, when we look at example, we only need to consider left outer join. Yeah. Yeah. All right. For the left outer join, then you need to think about, because you need to maintain the null values. Yeah. So non-matching field. Okay. Yeah. So then sometimes your query questions, you may use this property to do some special representation. Yeah. Here I do not have existing examples. I saw several examples before. Such example, I will try to find some examples. Yeah, because some students, sometimes in the question you cannot see the outer join. Yeah, so the case is like this. When you read the question, yeah, you cannot see any place. You need to use outer join. Yeah. So you have many different ways to understand this question. Yeah. So your algorithm could be different, quite different. There are many different ways. You can use inner join way to write it, but there is some smart way, yeah, pretty smart. So using the outer join property, yeah, so that those null cases, okay, special property, then you can, do some of the special questions. Yeah. So in that case, yeah, I try to find some appropriate examples. Yeah. 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 So, show you later. Yeah, sometime later. Yeah. Yeah. So let you see, we can use outer join to do many different things. Yeah. All right. Yeah. So that's the we complete the whole module 4. So next time we need to start module 5, our last module. Okay. our module 5, we have two halves. Yeah. The topic, two halves. Yeah. One half, still complex query. We have some more complex query topics. Yeah. It's more advanced. Yeah. So we can treat in module 4 our complex query part, the basic part. Yeah. Basic part. So inside complex query topic, basic part. But module 5, we will go to advanced part. Yeah. Still many special ways, techniques we can learn. Yeah. Some queries very complicated. Yeah. So we have some special technique. Yeah. We can, solve the problems. Yeah. So that's half of the topics in module 5. The other half, then we need to study the fast search algorithm. Yeah. So in DBMS, when you search, because the DBMS, the search performance is very important. The query response time, very important. Yeah. So then, think about when we need to search some particular row in a large table. How large? It could be millions of rows. The table could contain millions of rows. Big, very large table. How to make your search operation very fast. That topic. Yeah. So the other half we will learn the special algorithms used to do faster search on large table, especially the large table. Small table, so we don't need any special technique. Yeah, but for the large table, it's important. Special algorithms, very important. Yeah. So the main idea of the search algorithm, very simple. Binary search. Binary search. Yeah. So that's the main idea. Yeah. We just find a way to apply the binary search. Yeah. But the details, so you need to do a lot of detailed things in order to make your search to be able to apply on the binary search. Right? Yeah. So that's the two topics in module 5. Yeah. All right. Now, I have some time. Yeah, let me go to the sample project part. I posted 2 sample projects, but actually the same version, but the features the same, but one is the regular JavaScript version. Another is the jQuery version. Yeah. So you can compare the difference. Yeah. Sometimes you can use jQuery way to make your code simpler. Yeah. And do more things with simpler code. Yeah. So I also give you the jQuery version. Yeah. All right. So let me explain. This sample project should contain all the features I described in our project. So project, I give you some basic features. Yeah. So this one should contain all the basic features. Yeah. Then you need to do the new features, right? Yeah. So other than the new feature part, you need to write your own code. Yeah. All right. Yeah. But the basic given features, yeah. So you can find from this sample project. Yeah. Yeah. I don't need to do demo, yeah, because in my project description, you see the edit, delete, update. You see all the actions. Yeah. So you have a picture. Yeah. In the description of the project. So here I can save some time in demo part. Yeah. I just explain the feature part. second page. I already gave you one page. First page, already page 1 given. Yeah. Now we can do page 2. Yeah. But before I move to page 2, you can see the first 3 rows. These 3 rows, yeah, top 3 rows, MN, in our University View version, we only have one parameter, MN, right? Yeah, I explained the MN parameter. But here we add 2 more parameters, CN and DIR. Yeah. MN, table number, menu, yeah, because we put all the 5 tables in our menu bar, top menu bar. Okay? Yeah. So we use this MN parameter to control all 5 tables. Yeah. But CN, C refers to column. Column, yeah. For each table, you have a column number, right? Yeah. For each table, so first, after you determine one of the 5 tables, yeah, you get to one particular table. You have certain number of columns, right? Yeah. Which column do you want to work? Yeah. Because we want to work on one particular column. Yeah. Okay. Yeah. Sometimes we need to work on the column. Okay. Yeah. Yeah. So here I show you a simple in the project. I have a feature. Sort the table based on one particular column. Yeah. Ascending order, descending order. You sort the table based on the value of one particular column. Okay. In order to do that, you need to determine which column you want to use to order your data, right? Yeah. So for that purpose, we need a CN value, parameter CN value. Yeah. The second parameter. Then direction. Yeah. When you do the order operation, sort operation, ascending order or descending order, there are 2 directions, right? Yeah. The default is the ascending direction. Yeah. If you do not specify ascending or descending, then the default case is the ascending order. Yeah. But sometimes you like to sort the table by descending order. You need to specify it. Yeah. So there are 2 directions you need to tell your program. Yeah. So which way to sort? So we use this DIR value. If it's 0, that's the ascending order. If the DIR value equals 1, it's descending order. Yeah. So each parameter we control one special property. Yeah. Here we have 3 parameters we use to control 3 different properties. Yeah. All right. Then I just move to the page number 2. Page number 2, yeah, here. Yeah, before we move to page 2, we already, so here, I just recall, okay, we get a table name. Yeah, so yeah, that's what we did last time. Then we also get a list of fields. So this query, our result 1, this query, we get a list of fields, and we store a list of the fields in the fields array. This fields array contains a list of the fields of current table. Okay, yeah. All right, so we have that. Yeah. So then, next, yeah, yeah. All right, yeah. So these are, so here. What's that? All right, when we go to the next page, let me set a starting point of our page number 2. So this is the starting point yeah, of our page number 2. Yeah. All right. Then I take screenshot. Oh. Yeah. Yeah. All right. All right. From here, I want to include the line number because I may need to refer to the line numbers. Yeah. That's our page 2. All right. Yeah. Make it larger. Yeah. All right. Yeah, this is our page 2. Oh, yeah, pretty good. All right. Yeah. Then, what is this array, right? Yeah. First, this here you can see the 5 elements in this array matching the 5 tables, right? Yeah. First table, student table. Yeah. But remember, we have a one array containing all 5 table names, right? We have that before. Okay? Table TBL ARR. Remember? Yeah. So here, I want to the first thing. Do not get confused. Okay. So we already have. Sorry, not here. We already have an array we used before called TBL ARR. This array contains the table names of the 5 tables. We already have that. Okay, yeah. But here you use another array, store the information for 5 tables. Is it, some duplicate copy? Yeah, yeah. So here, slightly different. Yeah. So this array, although we want to show which table we want to display, but therefore this is for display purpose. Display purpose. So, yeah, I want to explain. Yeah, because when you study the code, you may get confused. Why we have 2 arrays to store the table names, right? Yeah, it looks like unnecessary. Yeah. Here, I explain my intention, why I use 2 different arrays. This array we use for display purpose, so we want to print out, display for our users. The users will view these 5 names corresponding to 5 tables. Yeah. So we want to that means we want to make it user-friendly. Yeah. But our original table names not necessarily user-friendly, right? Original table names just for internal usage. Internal usage, we like to use the ways that programmers like to use, right? Yeah, programmers like to use. But for the version facing the users, that could be slightly different, right? Yeah. For example, facing users, usually we don't want to use underscore, right? Underscore. Yeah. So we use space, 2 words, space. But table names, you cannot use space, right? Yeah. Table name is space there. It won't, because table name, you should have one string, the string without space for the table names, right? Yeah. So when we display the table names for our users, we should make some necessary change. Yeah. So here, you can treat this array just a user-friendly version of table names. User-friendly version. Yeah. Yeah. So you can modify the table name because that's for display purpose. When we do query, we won't use these values to do query. Okay? When we do queries, we need to use the original table names. So we need to use that array, okay, for queries. For display purpose, we use user-friendly version. Yeah. That's the reason there are 2 different versions for table names. All right. Then, to prepare data for display, here I use a 2D array, data 2D array. Yeah. Here, this name, yeah, because 1D array, 2D array, yeah, sometimes it's hard to separate. So here, I intentionally put a 2D, yeah, so make you aware of it, okay? Yeah. So in your mind, you should imagine, oh, this is a 2D array. Yeah. There are rows, there are columns. Yeah. You need to, mentally prepare for that special structure. Yeah. All right. Then we need to populate this 2D array. Yeah. So the data in the whole table should be stored in this 2D array. Yeah. So we need to display row by row, then for each row, column by column. Yeah. All right. Then to dir number 0, 1, you retrieve the data based on ascending order, descending order, right? Yeah. So here that's our query, okay? So for different direction, yeah, order by clause, yeah. So we sort the table, order by, yeah, field name, yeah. So here field name, yeah. The field array contains the column names for all the fields, but which field you want to select? We need a parameter, $CN, to tell us which field do you want to use to do the sorting. Yeah. Order by, then without ascending, descending, because default is ascending. Yeah. So for the descending case, we need to add this DESC. We need to tell DBMS we want to sort in that descending way. Yeah. All right, so after that, yeah, so your query. So you run that query, yeah, you get result 2. Okay? Yeah. The sorting result. Yeah, sorting result. Yeah. All right. Then you use a while loop to retrieve, and also at the same time, you populate your 2D array, yeah, row by row. All right. Then use a $line variable to contain each row. Yeah. Yeah. All right. Then we run this fetch function. Yeah. All right. Fetch function result 2. Yeah. Some parameter, some special parameter. Okay. Yeah. Associative. Yeah. Some arrays we can use associative array, right? That means we can use the string name as the array index. Yeah. Array index, yeah, supporting associative array. Yeah. All right. All right. So every time you retrieve one line, one row, yeah, in your query result, row by row, okay, for row, going through row by row. So for each row, you need to retrieve column by column, another inner for each loop to retrieve the values for all the columns. Yeah. All right. Then that line variable contains an array of field values. Yeah. It's an array. Okay. This line, yeah, because out of for one row you split into an array. Yeah. Array for each loop as column value. Each element of this array. So as this is the variable for each element. Okay? You split this is array. Yeah. Line split it into array. Every time you just take one element in this array, yeah, do iteration. Then you populate your 2D array. $I, yeah, yeah. All right. Yeah. Yeah. The first row, I equals 0. So the first row, this 2D array, the first index is 0, the first row. Then second index, consecutive location. Yeah, you do not need to specify number. We use the consecutive index numbers. Yeah. Then you assign the color to this element. Yeah. All right. So here, actually, you can see, here we increment. But in the next row, yeah, so here, actually, you can see, we use this counting variable, $I, point to the column, right? Yeah, so here, yeah. So here, I should explain a little better here, yeah, because look at every time when we are here, we always start from 0, right? What's the meaning? Start from 0, that means you want to retrieve the value of the first column and put it here. Second, then you increment it. Value of second column, then you put it here. Yeah, put it here. But you use the first index. Yeah, you change the first index. Okay? You change the first index. Yeah. All right. Yeah. So, a little confusing. Okay. Yeah. But after this while loop, you retrieve all the values, values for all the rows, columns, and you store in this 2D array. Yeah. Here. Yeah. All right. Yeah. Increment. Yeah. Here. Yeah. One question. Yeah. Before I move to the next page, one question. Yeah. Because for your understanding, you may have the problem here. Okay. There is a possible question mark here. Yeah. Think about. When the index number is empty here, empty in this position, what value should we use? Yeah, so here I want to explain that. Yeah, it's empty. What value we should use? Okay, yeah. The answer is very simple. Yeah. The next available number we use. Next available number is used. Okay? Yeah. So let me use a concrete number. Let me do a few rows to give you some idea. Yeah. Because this is the relatively hard part to understand. All right. Let me just do a few rows. Yeah. 1, 2, 3, a few rows, so you can see the, how do we populate the data here. Yeah. When we start row 1, right? Yeah. We start row 1. Row 1, okay? Yeah. All right. Row 1, we have indices. So here. All right. Yeah. So here, it is a little confusing. Yeah. All right. Yeah. Let me try to clarify this part. Show you concrete example next time. Yeah, because this part a little understand how to run the indices, 2D, and it's a 2D indices. How to run it? Yeah. So we need to be very careful. Yeah. All right. So next, let me show you another. Yeah. I have a few minutes. Let me show you another part. Display. All right. For the display, then to display the data, we use 2 tables to display. Yeah. All right. The first table display the title part. Yeah. So let me show you the title part. Yeah. All right. Yeah. Oh, yeah. Before I I change. Yeah, yeah. So because I want to keep this page. I do not want to throw away this page. Yeah. All right. Yeah, yeah, yeah. This page, yeah, because I do not have a lot of time. I just use this table to display. So the for loop. Yeah. So this for loop here, we display the title of the table. Title of, right? Yeah, the title part of the table. Okay, all right. The title part, the for loop, then we use OPT ARR. This is the user-friendly version of the table names. Yeah. So we run through. Yeah. We use the table structure. Yeah. Yeah. So then, yeah. Here, because when we display the table names, the currently selected table should be boldface. Yeah, we want to use boldface on the current table name. Yeah, yeah. The remaining four, yeah, just a normal case. Yeah, yeah. But how do you apply the boldface? Yeah, B tag, boldface. All right. Yeah, when the $MN value equals $I, yeah, the current index number, yeah, equal, yeah, so that's the current table, yeah. All right, then we use this B tag to make it boldface. Otherwise, we make a hyperlink, yeah, this A tag, yeah, hyperlink, yeah, to, yeah, yeah, so here, yeah, yeah. Let me look at the time, yeah. All right, href, the link, index.php. That's the name of the current file, index.php. Yeah, I changed the name to index.php, current file. Question mark. Okay. After question mark, we should attach a sequence of parameters. All right, after question mark, the first parameter called MN. MN equals the value, the PHP, this I value. Okay, yeah, I value. Yeah. All right, so this is a link. All right, then your table name. Yeah. Yeah. So other than the boldface, no hyperlink. The remaining four table names, each one you have a hyperlink. Okay. When you click it, you change the value, MN value, to this value. PHP, you print the value $I value. Okay, and that's the change the parameter. Yeah, yeah. In this way, yeah. So you can select table, different table. Yeah. All right. Yeah. So let's stop here. Yeah. Yeah. So next time we do one half theoretical part and one half coding part. Yeah. So I hope after some explanation you can understand the sample project better. Yeah. All right.